Have you ever wondered if buying a cheap used CNC machine is worth your time and money? Me too. So in this video, I roll the dice.
I need this. I'm about to go from ashy to classy.
And bought this cheap used CNC machine for $1,000. Will it run and make parts, or did I just throw my money right out the window? Let's find out. Nothing. That's not good. Welcome back to the channel. I'm Randy, and this is a Fadal 4020 Machining Center. So you're seeing it for the first time, just like I'm seeing it. All I did was unload it, which was a total nightmare. So the problem is that the load shifted because he didn't have it rigged right. So now I have to take the panels off the front and actually take some steel and cut it to 4 foot, stick it through the sides and try to grab it from the front because it was so tilted. We just spent half an hour just trying to get it back up level so that I can actually cut this stuff and get it on there. So I'm gonna be using this sick Evolution chop saw. I've had this for a while. I actually had a commercial bandsaw, got rid of it, and I use this. If you guys want to purchase one, I'm not affiliated, but I'll leave the link in Amazon where I got this one from. And it's got the stand with it. I bought the stand with mine. Bam, just like that. All right, so you see here what I'm doing? See, I got that 2x4 going through this pocket so I can come forward and hopefully grab it. And I set it down in here about a week ago, and it's sat here ever since. So I purchased this machine for $1,025. I got the typical backstory that you get anytime you go to look at any CNC machine. You know, they told me the owner retired, it was running when unhooked. I'm sure any of you guys that have bought machines have heard them same stories. It came from a clean dental lab. It only ran graphite. You know, all the lies that you hear when you buy a used CNC machine. So if there's anything major wrong with it, I can fix it for Fadal. So I felt pretty comfortable paying $1,025 for this machine. So let's take a look at it. So it looks like they had a little whiteboard for writing stuff here. Again, one of my pet peeves. I hate when people stick stuff to machines like this. You pay all this money for nice machines and you go and stick stuff to them and then write on them with like a marker. This doesn't make any sense to me. But then again, this may be employees that don't care about the equipment, you know. So both the doors are just kind of flopping around in here. It looks like they're missing the hooks on this side. And it also looks like they remade these pieces here for the inside of this plexiglass. It should be Lexan, but it's probably plexiglass. So one of the things that kind of worried me was when it came in, I saw that they made this custom block for the head. And I was wondering if they made that block way up high like that, were they not able to power it up to get it to go up and down so they could make one closer to the bed? I don't know. So it's got the Fadal CNC 88HS controller, which is good. It looks to me like it has the cow motion where you put the USB stick, which is, I usually upgrade my machines to that anyway. So that's an awesome feature with this machine. Looks pretty clean in there. They cleaned all the chips out. Looks to be in pretty good condition. The back looks immaculate. So if you see the back of the machine, look how clean it is. So another thing, they told me this was a 2012, but when I get it and look at it, it's actually remanufactured in 2012, which I don't know if that's a good or bad thing. I mean, if it was remanufactured by thefadalparts.com, I've never had one remanufactured by them before in California, but this could very well be like a 2012 ground up build. So it could be a really, really good machine. I guess powering it up will tell. And you can see everything here. Spindle chiller looks clean. The case, everything looks really clean on this machine. Even the coolant tank, you know, they're usually pretty nasty, but that one looks pretty clean. So I guess first things first, let's see what we can do about these doors. If I can't get them right, I'll take them off, put that side door on. I also have to look in the back to see if the counterweight was blocked up, because sometimes I forget that and people have actually done what they're supposed to do and block those up. And then you go to power it up and the servos freak out because it's trying to go up and it can't. So first things first, let's get these doors figured out and then we'll go from there. Okay, let's see what's up with these doors. So there is a hook on this side over here, but no hook here. And it looks like they customized this to put plexiglass up there, but there's no plexiglass. And the spring and everything is still in there, so maybe it will just hook in. Let's see. Okay, that's on there. Okay. A little noisy, but it works. It actually stays up in there without this hook being here. Huh. A little bit of oil, that should be good. So this one should go the same. Nope. That was not going to be easy. It's not moving, but I got it. Ah, there we go. All right. This one sounds better than the first one. Nice. Let me get this side door out of here. So now that that's out of there, we can actually see the inside. Doors slide pretty good. No problems. Inside looks pretty good. You know, the normal powder coat is wore off a little bit, but nothing too horribly bad. So now let's go around back and see if they actually blocked up the counterweight. Okay, so typically when these are blocked up here, it's behind this panel right here by the power. It looks like it could be blocked up in there. Let me get this panel off right here, see what's back there. Okay, so I got this panel loose right here, the 4 bolts that hold it in, and then when I went to unscrew this one, I could hear the counterweight move. So that's definitely blocked up right there, this one and this one. So what I need to do now is power it up and kind of move it just a little bit in the Z direction to kind of release the tension on there so I can pull those out. So that's the next thing, is getting some power to this thing. So what I always do when I get a fidal in is in this back panel here, they have these transformers and jumpers, and I try to line up what my power is with what the jumper switches are. So in this one, let's see, it looks like A2, A5, and A6. So let's see, 2 and 5 and 6 is set to 210. And I know that I have 230 coming out of my phase converter, so I'm going to do 2, 6, and 7. So what I need to do is take this line and jump all these to 7, and I should be good. Easier said than done. This is kind of a pain. I'm used to it now and I know how to do it. You need like a little pick, and you push the pick down in there really hard to release the spring while you pull the wire out. It sounds like an easy thing, but it took me a while to be able to figure out how to pull these out without ripping them. Okay, so what I found that actually works best on these push pins is this little T-handle hex wrench here, and you kind of get the one that exactly fits in there and push it really hard, and these wires pop out. And then you push it really hard and get them back in there. So that's 7, 7. This one's on 6. Ugh. And put this one on 7. Let's see. It doesn't look too good. And that one on 7. Go. So now we should be set up to run on 230. All right, so I got a power line ran to it. Let's get this phase converter turned on. This one. This one. That one. Okay, so this is going to be the first power up of a CNC machine at my new location. If you haven't seen the video about how I built this location for $3,250, go back and check the video out. It's doing really good right now. It's up over 280,000 views. Pretty good video, only 9 minutes. Go back and check it out. This is the building, 2,100 square foot, if you're into that type of thing. All right, so here we go. Fingers crossed. I hear stuff coming on. Oh man. Okay, so let's see. Hold the power up button. Oh, I hear movement. Let's see what we got. Oh yeah, screen's on. It's really dull, but it's on. But it is a LED screen, so I don't know why it's so dull. I don't know if you guys can see it, but it's really dull. So it's saying jog the machine. What I'm actually gonna do is power it down and unblock it, and then we'll jog it around a little bit to try to get that counterweight off. All right, so I got this bottom one loose. I actually didn't power it down because I wanted to warm up and see if the screen gets brighter. All right, so that one's out. Got it. All right, so let's see if I can jog it up just a little bit, just to relieve that and kind of knock that out of there. Yeah, it's in there pretty solid. Oh yeah, it went up just a tiny bit. Bam. So it does move, which is awesome. So what I got to do is jog it up and down just a tiny bit and see if I can pull those bars out of there. But what a score. Yeah! All right, so here's the bars here. When I started turning them with that wrench, they moved. Here's the other one, I assume. This is what they're using to pull them back with. So this plate is captured by these nuts here that they got on here for pulling these out. Pull that out. Go get that socket again and take that off. Okay, so when I try to pull that one off, the actual bar is rotating. So I may not be able to get this plate off. I have to leave that on there. So the thing that kind of sucks is I don't know if the head needs to go up or down to loosen this, to get this loose. But I guess we'll just jog it around and find out. So let's go down just a little bit. Right there's where it was. I'm assuming maybe like right there. Nope. Okay, so let me jog it around back and forth. Don't need to waste your time with that, and see if I can get those loose. Okay, so I got these where they're almost ready to pull out here. See how loose they are? It would be nice to get this out of the way, but it's kind of captured here. But yeah, so I just moved it up and down slowly until I got it where these were free. And these should come right out of there. There goes that one. Maybe I can move this out of the way here. There we go. And there goes that one. So that's how you unblock a counterweight on a Fadal. All right, so we got that released. Goes up and down, nice and smooth. Let's line all the marks up inside and do a cold start. So I don't know if I can see the one on the side there. Usually when you roll it up, you'll see it. Hopefully. There it is. Right there, the line's lined up there. You see there's a line here in the front. It's gonna be the X, that on there. And then there's also two lines down here that you have to line up. So let's cold start this thing. Been a while since I ran one of these, and I don't know if you guys can even see the screen or not. But let's go to 9, cold start, continue. And the machine should kind of jog itself around here. And it did, boom. So now we go to manual. We're in there, good start, good start. So let me hook some air up to this thing now, because we do need air to do a tool change. And I'm not sure how they got the air set up on this, but let's see here. Okay, so it looks like they got a block there. Probably goes out front. The other one is cut, so I imagine they were supplying it right there. And then it was going out front and here. So what I'm gonna do is try to take this off and then take this off and just put a fitting in there so I can just stick air right into there. Okay, well, I got some air going to it. If you guys can see, there's actually a program still in here that they ran before. But let me go into MDI, see if we can just get the spindle moving. M3 speed 500, enter. Oh, I didn't hit enter. Look, the work status light even works. Those never work. So let's see. Sounds good. So there's actually 2 belts inside of the top there, and they'll switch between high and low gear. I think high gear is like 2,500 or 3,000 RPM. So let's see, speed 1,000. Oh yeah, that thing sounds smooth. So let's try to kick it into high gear, speed 3,000. So what it should do when I hit the enter is it should pause, second belt should kick in, and it should go into high gear. There it is, paused. I can hear the air switching it. There it goes. Wow, that spindle sounds phenomenal. I think I'm pretty lucky on this one. I don't know yet though. Let's do a tool change. So let's go M6 tool 3. Enter. There it is. Beautiful tool change. And I really shouldn't, and I know you guys are gonna get on me, I really shouldn't even run this spindle without a tool in it. I do have a bunch of tools over here. Maybe I'll stick one in there real quick. Let's see what I got. So here's just a bunch of random stuff. And I can't remember what tool tabs this takes. If it's the big ones or the small ones. I think maybe it's the small ones. I know I've used these in there. It actually should say on here. Let's just stick one in here and see what happens. If it's not the right size, the worst thing is it just won't hold it. Let's see, tool in and out. Oh yeah, she's in there. Now I got a tool in there. Let's see, M6 tool. Let's go 5, see if it'll put that into carriage. Enter. Oh yeah, perfect, man. I want to say this one's a score, man. Like, we'll see if we can machine some parts with it and see if this cow motion works in here with the USB. It's been a while since I've done any programs on a FDAL, but we should be able to get it. I got internet in here. We should be able to get on Fusion 360 and make a program, see if this thing runs. Let's see if it'll pick the tool back up. M6 tool 3. Beautiful. So far, so good. So let me get a vise in here, set this up, and see if we can actually run a part with it. See what kind of tolerance we get. It's not level out or anything like that. I still got to pick it up and level it out, but we can machine something little just to see if we get decent tolerance out of it. So let me get everything set up, and then I'll bring you back. Okay, so I found my Heimer gauge and a couple of my tools that I usually use and a vise. So here they are here. What I'm going to do is try to dial in this vise real quick as good as I can. Indicate off the back jaw of this vise, which I cleaned and sanded to make sure it's smooth. And just to see how on level this thing is, if you look here, this thing is almost perfectly level. Like, I know this isn't a machinist level, but it's right inside the bubbles, like perfectly. So that way and this way. So I'm not going to sit here and make precision parts on it until I sit and level it perfectly, but with the machinist level. But this one shows that it's kind of level, so it's pretty good. So let me dial in this vise. Okay, so it took a little doing. It's been a little while since I indicated a vise in, but I got it pretty dead nuts. This is a 5/10 indicator, and you can see when you run it across, barely moves, barely. Not at all, actually. That's pretty bang on right there. So let me get some tools loaded, get a little program together, get me a block of aluminum in there. Let's see if we can machine something. Okay, so I got the vise trammed in. I've got 3 tool offsets set. if I remembered how to do this correctly, use my Heimer gauge as tool number 1, but I took that out, and I used my measurement block over there. I have this program here designed. You can see it's just a block, just a simple block, and then it'll face it, do the outside, and do the pocket. So I exported it. Hopefully I remember how to do this. This has a little cheat sheet on it for the cowl motion. So it says DIR directory. That should show you everything that's on that stick. So first thing you got to do is open up the port, which is CD, 10. I do remember that. Okay, now DIR plus should show us what's on the stick. DIR plus, and it did. So you can see there we've got all these programs on that stick that I had on there. This is the new one that I just made. So then this is all starting to come back. So TA, what is it? TA, if you want to drip feed it, it's TA, comma, file name. But I don't think I want to drip feed. I think I want to bring it in, and I can't remember how to do that. Let's see, tape. View tape input, TA, comma, file name plus. Oh, so that is how you bring it in. So TA, comma, file name plus. TA, comma, file name 5123 dot NC, and then plus should bring it into the controller. Parameter error. Let's see, TA, comma, 5000.NC plus. That did not work. Make sure I'm reading that right. TA, comma, the file name and plus should be tape input. Try it again. TA, comma, 5000.NC plus. That's not working because usually when you hit the plus, it'll just automatically work. So let's try again. CD, comma, 10. Let's open up the channel. Boom. And then TA, comma, 5000.NC plus. There it goes. There it goes when you get the little @ sign. See it running into the controller? Bam. What a freaking score. It had that in there. That's crazy because I always have to add that, and that's pretty expensive when you do it yourself. So let's go back into manual. Let's see. And there it is. 5,000. Nice. So assuming that I have all my work offsets set up correctly, it should grab tool number 2, which is the face mill, and it should come down and do like a 3 thou pass over the top twice, and then it should put the tool back, grab tool number 3, and come down and start doing its thing. So let's see, feed rate, rapid travels, turn that down, block skip, no. So I guess we're ready to rock. Let's just keep our hand on this, keep our fingers crossed. Let's go to auto, start 1, close doors or clear external slide. Don't tell me this is hooked up. Oh, I bet you that's hooked up. I hate that. And that's broken too. The door thing is hooked up. Let me remove that and tape it to there, and we'll try again because we're not going to be able to see through these doors. Okay, so I've taken that thing off of there and taped it on here. So hopefully that release will work now. Let's pick up where we left off and try again. So let's go to auto, and I guess you just hit start. Oh yeah, there we go. I got it going real slow here. So it looks like it's going to do the tool change. I got the rapid travels turned down 25%. Let's see if I got the offsets right. I'm not quite sure about that. I'm gonna go real slow here, because I'm not really sure if I have these offsets right. So I've also got my feed rate down. I got my spindle at 100%. My speed is 1570 on that cutter, which is pretty slow for what we're machining here. But I'm gonna close these doors up a little bit. Let's see. It looks like it's going down a little bit too far. Yeah, my offset's messed up. Yeah, it's offset's way messed up. Look how far down it came. It should only be coming down 3/1000ths above the stock. Let me try to figure out what I did wrong with the offsets and I'll bring you back. So let's see what happens with that. That looks about right. I did throw my safety glasses on here. Yeah, it's barely skimming the top. I don't know if it's really doing anything. Yeah, that looks about right. Because you can see there, it did take a little bit off. See that little chunk there? And I did measure this from the middle. So I only programmed it to go down 3 thou. So that may not have been enough. Or I may have measured the offset of that tool wrong. A couple of things could have happened there. So it is machining a little bit. Didn't really knock anything off. It knocked that corner off nice and smooth. So now it should go to the next tool, thumb down, go around and start going around the outside. Turn my feed rate back down. See if I got my offset right. Because I did the front left corner. I usually do the back right, but this program was already set up, so that's why I just went ahead and rocked with it. And I'm also stopping the program here, slide holding it, so it looks like that's about the right amount down. So as long as it doesn't hit too hard, I guess we're good. It looks like it's gonna just barrel right into there. No, it's going around. Okay. There we go, it's machining. Yeah! So let's bump this feed rate up. 85% feed rate. Nice. Actually looks like it's doing a really nice job. Like I said, I think I got the step over at like 3 thou step over. It's not a lot, but it's enough. It's blowing those chips right off of there. Sounds good. A little jerky around the edge passes, and that may be because in the program I may not have smoothing turned on. I don't know why it's jerky like that. It's got to be something in the program, because it's running right from this, the program in the machine, so. See how it's pausing there? So I also machined in that pocket in the top. Let me get through this, bring you back for the pocket. All right, so I got the outside perimeter operation done. Now it's getting ready to basically plunge down inside of there and do the cavity. Let's see how that runs. I never did figure out that jerking that I was getting in there, but it didn't come out in the surface finish on the end, so let's see, let's do this real slow here. There we go, it's starting to plunge. I turned it down to like 40% just to be safe. And I can see right now, well, it's the plunge hole, so maybe the plunge hole is way off. But if that's the final hole, it's way off. See it on the... That's way off. So there might be something off with my work offset also. Like I said, it's been a long time since I machined, but I doubt it, because it looks like it took an even pass all the way around the outside. So I don't know why that circle would be so far off. But maybe that's just part of the program. I didn't run the simulation to see what it does. Maybe it just opens that hole up on the side and then goes into it, which is kind of looks like what it's doing. That is what it's doing. So it actually did the hole on the side to open up a path so it can come in and go like this and just hit the side and hit the side and hit the side. Like I said, it's been a long time since I've been machined, moving into this new place and trying to get all this together, so bear with me. And I'm not the best machinist to begin with. There it is. Wow. $1,025 machine that actually machines. Let's go to jog. Let's get this up here. See what we got. So all in all, that's got a really nice surface finish on it. You can see my finger there. And like I said, that jerking I was getting in the beginning, it went away towards the end, and it really didn't affect the surface finish at all. Inside and out. You can see my reflection. So that's pretty good. Now let's measure the part. Let's see what I even have this at here. So from here to here is 0.8. Let's see what we get here. All I got right now is this cheapo Harbor Freight micrometer because I can't find my other stuff. That's what happens when you move. It doesn't even have the part that comes down the bottom. But let's see. Let's just give it a go here. Yeah, man. That's right to the edge. 0.79. So let's see, what did I make the square here? This and this. 1.5 inches. Wow, right on the money. And then here. Thou difference, but it could be the micrometers too. You know, these are just cheapos, but wow. Wow. That's pretty good. That's pretty good. So let's see what the hole is. The radius is 0.5. It's going to be hard to measure with these, so let's just do our best with this. I'm pretty sure if everything else is on, this is going to be on. Let's see if I can get around here. So that's 0.99. 0.99, 0.98. What did we say it was? Oh, the diameter. Oh, it's 1. So I was looking at the radius. Yeah, the diameter is 1 inch. So it's 0.99, 0.98. That's on the money. You cannot complain about that. For $1,000 mill that's not even leveled, sitting right on the ground, that's pretty impressive. So what do you guys think? Did I score? I think in my book, that's a massive score. $1,025 for a machine that runs like that, holds tolerance like that right out the box. It's not even leveled. It's sitting right on the floor. I don't think you can beat that. I appreciate you guys tuning in. If you want to help support the channel, it's freezing cold outside. Go to the link below, purchase one of these beanies. You should see them down below here. I had these custom made. These are really nice and soft, one size fits all. I'd appreciate it. It really helped me support the channel. Give me a follow and a like on this video. Helps bump the algorithm up. And I'll see you guys on the next one.